Hello guys, hope all of you are doing great. This is Dr. RCB and you're viewing my channel Computer Science with Dr. RCB. This is part 2 of the video series where we are learning the fundamentals of Python programming language. So if you're someone who wants to learn Python from basics to the advanced level, then most probably you are at the right place. The link of the playlist is given in the description section, so please check it out. Okay guys, then let's begin today's session. In this part of the video, we'll be talking about operators in Python programming language. There are different categories of operators in Python. But here in this part of the video, we'll not be talking about all these different categories. Rather, we'll be talking about three simple categories of operators. And once you people understand how to use these operators in a program, then you will be ready to actually learn about all the rest of these operators. Before actually going through these different categories of operators and distinct operators under a specific category, let me tell you one thing. This is not about remembering what are the different categories of operators there in Python. It is not about remembering what are the distinct operators there under a specific category. Rather, it is about learning how we can use these operators in a program to solve some specific problem. And that's what we're going to learn in this part of the video. For that reason, what I'll do is first I'll be demonstrating you what these operators do in their individual level. And then at the end of the video or towards the end of the video, I'll keep a, you can call it practice session or check your understanding session. So there what I'll do is I'll be showing you a list of programs, and what you can do is then you can pause the video there and you can try to write the programs by yourself. When you see that list of programs, you'll realize that, okay, these operators are really very useful. Without these operators, writing those programs would have been very difficult, at least, right? So I request you people to go through this entire video. Do not skip the video. Go through this entire video. First, see what these operators do at their individual level, and then when you reach that point, check your understanding part. Then you can pause, and then you can actually try to write those programs by yourself. Okay guys, then let's start with these first category of operators, that is arithmetic operators. You have already seen some of, see here, this is the category of the operator, arithmetic operators. It is the category, and under this category you have these 1 2 3 4 5 6 7 operators there. Okay, so like this plus symbol, this is the symbol of the operator that you use in the programming language, and it is the name of the operator. So it is this plus is called the addition operator, minus is called the subtraction operator. When you write two stars together, it will be called as the power operator. Now see here, an operator, it is not necessary that an operator is always a single symbol. It could be a combination of two symbols also. They might be the same symbol twice, or maybe they, you will see in the next category that they could be a combination of two different symbols also. Got the point? Okay, then now you might have already, actually you have seen these plus and minus and multiplication and this division, but then also let's learn them more formally. Okay, then let's first see these plus operator. Okay, so for example, you have a variable. By this time you already know what is a variable. So let's say you have a variable a, and where we'll be storing these numbers, say for example 10. Okay, you have another variable, say b, and where you have stored this number 20, and semicolon is not needed. Yes, b is equal to 20, and then suppose you want to compute the sum of these two numbers. Okay, so in that case what you can do is you can declare another variable, say s, and or let's call it say c, and in that case if you want to compute the sum, you'll be writing it like, okay, c is equal to a plus b. So this plus operator is used to compute the sum of its operand. Now I'm using a new term here, this operand. Okay, now let's see, let's first learn what is an operator. This plus is an operator, already you know. An operator is an operator is something that performs an operation, a specific operation on some data, and on the data on which it performs the operation, they are called as the operand. So for example, in this expression, this entire thing is called as an expression. Okay, in this expression, this plus is an operator, and this a is the operand, b is another operand. And see here, actually in this entire expression there are two operators there. One is this equal operator, that is also an operator. See here, it is an operator. As I said, now what an operator does, it performs a specific operation on its data. Like so when I say this equal is also an operator, you can see that, yes, right, it is performing an operation. And what operation it is performing? Whatever you write on the right hand side of the operator, that value is stored on the variable or in the variable which you write on the left hand side of the operator, equal operator. Okay, that is the, like, the operation that equal operator performs. But anyhow, we take that equal operator for granted, right? Yes, okay. And now talk about this plus symbol. That plus symbol is also an operator. Why? Because it is performing the addition operation on these a and b. So in this case, this plus is the operator, and a and b, they are the operands of this plus symbol. It means this plus symbol is performing the addition operation on these two operands a and b. So as you know, like, what will happen when this expression is executed? First, it will perform this. First, it will compute the value of this right hand side part of this equal symbol. So it will it will perform what is a plus b. So a plus b means it will go to the RAM, it will check a is 10. It will check what is the value of a, which is 10, and again it will go to the RAM, it will check what is the value of b, which is 20. Then it will compute 10 plus 20 is 30. That 30 will be stored back in this variable c. So as a result, now if you print c, you should be able to see 30 on the screen, right? No, it's very simple, right? This plus operator is very simple. Similarly, if you want to compute, say, the subtraction, then you can write print a minus c is equal to a minus b. It'll compute it will subtract the second operand from the first operand. This minus is the subtraction operator, and its operands are like these a and b here. So what operation it performs? It subtracts the right hand side operand from the left hand side operand. Clear? So here it will perform 10 minus 20, which is minus 10. Okay. Similarly, this multiplication operator. Multiplication is like, obviously it doesn't need any explanation. It means it performs the multiplication on the given operands. Similarly, this division operation. It performs the division operation on the given operands. Like, it divides the left hand side operand by the right hand side operand. So for example, if a is equal to 10, b is equal to 20, and if you write c is equal to a divided by b, then the result will be 0.5. The result will be 0.5. Now we already have seen this addition, subtraction, multiplication, and division. So they were more or less quite familiar to you. Okay. Now let's talk about this power operand. Now this power operand is, this power operand is, as the name itself indicates, if you want to compute the power, that is, if you want to raise the power of something, then you will be using this power operand. Say for example, you want to compute a raised to power of b, then what you will do is, say, you will be writing it in this way. Say for example, a is equal to 2 and b is equal to, say, 3. So a raised to power 2 raised to the power 3 is 8. Say you want to compute it. 2 to the power 3, suppose you want to compute. Then how will you compute it? Say for example, c is equal to a. You will write two multiplication symbol together. Those two symbols, it is not that you're performing multiplication twice or something. Those two symbols, if you write, if the computer sees, that is the Python interpreter actually, but in general I'm saying here as computer, if the computer sees two multiplication symbols together, it will understand, okay, the operation specified by these two multiplication symbols is the power operation. So in that case, if you write, say for example, a star star b, it means it knows that you are actually trying to compute a raised to the power of b, or a to the power of b. Okay, so as a result, now if you print the value of say c, you should see an 8 on the screen. 8 on a screen, right? So it could be anything actually. 10 raised to the power of say 3, it is 1000. So 10 raised to the power of 3 is 1000. So 1000 you should see as an output. Clear? Okay, okay then. Now done. You people have learned like what is power, what is division. Now what is this integer division? I mean, you can see here, like when you write this forward slash symbol only once, it represents division, or you can say it is like the floating point division. Okay, but sometimes it is it is necessary that you just want to compute the integer part of the division operation. See, whenever you're performing an division, actually there are two results, right? One is the integer part of the division, one is the fractional part of the division. So for example, here you see, even if I write like 10 by 2, the result is actually 5.0. So the integer part is 5 and the fractional part is 0.0. So sometimes it is important that you will see actually when I'll be showing you the list of the programs there, you will actually feel the need of integer division. So here I'm only telling you like what is an integer division and how how they work at individual level. Okay, but the actual one use case at least I'll be showing you when I'll be showing you the list of programs. Okay, now see here, when you perform 10 by 2, as I said, there are like two results actually, like two parts there. One is the integer part of the division, one is the fractional part of the division. Okay, so if you want to compute only the integer part of the division, then you have to actually use this integer division. So for example, a is equal to, just again, a is equal to 10 and b is equal to 3, and suppose for some reason you want to compute the integer part of the division. Okay, so in that case what you can do is c is equal to a integer division by b. Okay, and if you print the value of c now on the screen, what you should see is okay, 10 divided by 3, actual result is 3.3333, like that. But here, since you are computing the integer division, it will be showing you a 3. It will be showing you a 3. Clear? Now let me give you an example, I mean, where you can actually use it. Okay, let me change this value. Say for example, a is equal to some number 3452, some number I have selected. Okay, and then b is equal to this specific number 10. Now if I compute now the integer division, you can see here the result is 345. From here, okay, 345, the result is 345, right? Now let me change this number. Let me take another number like 7865 or something like that. Okay, and then again I compute the integer division. Now it is 70864. Just to show you the pattern, let me write the same code here once again, but this number let me change, say for example something like this. Okay, and then I run this program. Okay, now the output is 652. When the input is like a is the first number that you are actually dividing by 10 is say 78645, then the output is, when you perform integer division by 10, you get the output as 7864. Say the number is 6523 and you divide it by 10, integer division, you get the output as 652. From these, do you see some pattern there, like what actually it is doing or what you can do? Yes, what you can do is actually, you see here, if you want to, for some reason, if you want to get rid of the last digit of a number, then you can simply perform a integer division by 10. Say for example 78645, integer division by 10, it is showing you the first it is showing you all the digits. The result is all the digits except the last digit, 7864. 5 is gone, right? Because since you are dividing it by 10, it means the actual result is 7864.5. Since you are taking only the integer part, it is 7864, certainly, isn't it? Here also it is the same case. Since you are dividing it by 10, the actual result, I mean, if you're performing floating point division, then it will be 652.3, right? Floating point in the sense like fractional division, it will be 652.3. But since you are computing the integer division, then certainly the result will be 652. Got it? So whenever you want to get rid of the last digit from a number, then the solution is that, okay, you divide that number by 10, but don't do fractional division or floating point division. Rather, you do integer division. Then you'll get your answer. Clear? This trick we'll be using at, in some of the programs. So that's why I told you. This is just a hint. You can consider it like that. Okay, done. Now, you people have learned like what is this integer division by this time, right? Now the modulo operator. What is this modulo operator? Now again, it is related with this division, right? As I said, now for division there are two parts. One is this integer part and one is this fraction part. Now it means what? Like, what is this fraction part? It means like, say for example, if you divide a number by another number, then it might happen that sometimes you can divide the first number completely by the second number. But sometimes it also might happen that you cannot divide the first number completely by the second number. Okay, it means you can divide the first number by some integer part, and then there is something called as remainder. That is some portion which you cannot divide completely by the second number. So if you want to know what is left after division, then what you can do is you can use this modulo operator. This explanation I can like put it in a single sentence. Like, if you people are familiar with mathematics and if you know what is a modulus, then this modulo operator performs exactly that modulus operation. Okay, it gives you the remainder of a division operation. And the symbol is this percentage symbol. Don't get confused. It means the symbol is percentage, but it has nothing to do with the percentage. Okay. Okay. Let's see some example. Then you'll you'll come to know it more clearly. So, for example, you have a number like, say, a is equal to 3, 4. Let me give a small number so that we can verify our result very quickly, very easily. A is equal to 10, and say b is equal to 3. Now, if you write, say, C is equal to A mod B, and we simply call it mod, okay? We don't call it A percentage B, we call it A mod B, okay? Now, A mod B, if you compute, then what it will do, as you know, it gives you the modulus, right? It is actually the modulus operation you're performing. So when you divide A, that is when you divide 10 by 3 times you can completely divide, right? 3 into 3 is your 9. So after division, what is left? Like, after performing integer division, what is left? The left is your 1 here, in this case 1, right? So that 1 should be the value of this variable C. Let's see if we print C, what we get. You get a 1 here as a result. Clear? If you people have any doubts or any confusion, then you people can let me know it in the comment section. I'd like to help you guys in that case. Okay. But I'm just assuming that, okay, people are understanding up to this point. Now, let me give you some more examples. So at least one or two more examples on this, okay? Before actually proceeding further. Things are very simple. I mean, when I talk, like when you see them at individual level, obviously they are very simple. The thing is, again, I'm saying you like how to use them to solve a specific problem, or how to use them when you write some programs of your own. Then that is the actual thing that you should know. Actually, certainly you should obviously know what an operator does, but I think that is comparatively straightforward than actually using them in some in some program by yourself. Okay, and again, I'm telling you, it is you don't have to remember anything. Actually, the only thing is that you people have to do some practice, and as soon as you do that, automatically you will remember everything that you need to remember. Clear? Okay, now let me give you another example. Say for example, just try 34 mod 3. You want to compute 34 mod 3. What will be the output? So you can divide 34 by 3 how many times completely? I guess it is 11 times, right? After 3 into 11 is 33, so you get 1 as the remainder. So this time also the output is 1. Say for example, it is not like 3 now, it is say 5. So you can divide 34 by 5 completely 6 times. That is 5 into 6 is 30. And then what is left? 4 is left, right? So if you see the output now, it will be 4. Clear? So basically this modulo operator is computing the modulus of the first operand with respect to the second operand. Clear? Okay, now let me give you one specific example. Now let's consider any number. Okay, I'm randomly writing a number here, 53553. But here this B other number, the second operand, I'm writing here this specific number 10. Now let's see what is the output. Can you predict? Yes. The output is here, you see 3. No matter what number I write, see here 53553 modulo 10 is 3. Now let me write here, say another random number, another random number, say 56132, and modulo 10 is 2. From here, can you see a pattern? Do you see a pattern there? Yes, right. So if you compute the modulo 10 of any given number, then what you get? You get the last digit of that number, right? So for some reason, if you want to separate the last digit, that is, you are interested in only the last digit of a given number, then what you do, you just compute the modulo 10 of that given number, you will get the last digit. Now see, the two things I told you, right? If you want to get rid of the last digit, then you will be computing the integer division. If you want to extract the last digit, if you want to separate the last digit, then you will be computing the modulo 10 division, right? That is, you will compute the modulus 10, you will get the last digit. Clear? Right? Yes, if it is clear, then it's good. If it is not clear, then just pause the video, think for a moment what I just said, and it should make sense to you. Okay, let's see here. I mean, you always have to, whenever you want to learn something, you always have to spend some time of your own, like, in thinking, like, okay, to digest the concepts. Okay, and automatically, once it is digested, you will remember it forever, and you will be able to use it intuitively to solve some specific problem. Clear? Okay, I mean, that's understood, I guess, right? Again, we'll be seeing some, at the end, as I said, no, I'll be showing you a list of programs where we'll be actually using this modulus 10, this modulus operation to separate the last digit from a given number, and we'll perform some operations, okay? You'll come to know it when we reach there. But up to this point, things should be clear. If it is not, then people can let me know it in the comment section. Okay, done. Okay, then that much only about these different arithmetic operators. Now we are ready to move to the next section or next category of operators, which is comparison operators. Okay, and under this category, you have again 1, 2, 3, 4, 5, 6 different operators there. Okay, and these are quite straightforward operators. Okay, now let's talk about this greater than operator. Now this is the symbol, this is the name. Like this is the greater than, this, when you write this greater than symbol, I mean, what should you call it other than greater than, right? It is called as greater than symbol. Okay, now this greater than symbol is the operator, and it is the name of the operator that we use to like when we speak about it. So it is greater than, it is another one is less than. This is called as greater than or equal to. See here, I said you that two different symbols could be used together to represent a single operator. So here is an example, greater than and equal symbol. If you use both of them together, one after another, without any space in between them, then those two symbols together, Python interpreter or the computer will see it as a single operator, and that operator is greater than or equal to. Similarly, it is less than or equal to. When you use two equal symbols together, it will be called as equal to operator. There might be some confusion with, like, when you use single equal, when you use double equal. I'll come to that point. And then when you use this specific symbol not, this symbol itself is called as not. Okay, we call it not, at least in terms of programming language, we call it as the not symbol, not, N-O-T, not. Okay, and when you write that not symbol along with this equal symbol together, that represents an operator that is called as not equal operator. Okay, I just only said you the names of the operators, right? But anyhow, that's the starting point. Now let's see the the use, or how actually this operator works. Let's see them. And as soon as you know what this greater than do, or what this greater than symbol, greater than operator does, you will know the rest of them automatically. So let's start with this greater than symbol. Okay. Now these are called as comparison operators. And one very specific thing about, or peculiar thing about these comparison operators are, they always produce the results in terms of either true or false. It means, well, okay, let me give you an example. So for example, A is equal to 34, B is equal to some number 90. And if you write A greater than B, okay, Now see, when you write a greater than b, you are actually, this is an operator. Greater than is the operator here, and a and b are the operand of that particular operator. It means what? You are actually performing the specific operation represented by this greater than symbol on these two numbers or two variables a and b. So obviously it will produce a result. See, the way a plus b, the way like see here, where did I write? Oh, anything, a plus b or a divided by b. The way a divided by b produce the way a divided by b produces a result, the same way a greater than b also produces a result. On the same note, the way a mod b produces a result, a greater than b also produces a result. Now, on the same note, now actual thing, on the same note, the way you can store the result produced by a mod b in a variable c, the same way you can store the result produced by a greater than b in a variable c. And then you can actually print the result and you can check what is that result. Now let's see what is the result of computing a greater than b when a is 34, b is 90. Okay, let's see the output first, then we'll move further. Now see, the output is not a number anymore. The output is a word, and that word is false, right? As soon as you see the output is false, you should realize, what this operation is actually, what this particular operator is doing. It is actually sort of saying that when you say a greater than b, based on the current values of a and b, whether that particular statement is right or wrong. What it means is that you can think it of in this way. Okay, you can think it of, okay, let me go here and then add a text section, and let me type here something. That is, that someone is saying like this: 23 is greater than say 34. This is a statement, say, made by someone. Now your task is to say decide, or your task is to say whether that particular statement is right or wrong. But rather, instead of saying right or wrong, you'll be saying that that statement is true or false. Okay, if I ask you whether this statement is right or wrong or true or false, what will you say? You will say 23 is greater than 34. You will say that statement is false, right? The same thing is done by here. Like, say, instead of writing 23, 34, let me write here, say 34 is greater than, say whatever that number is, 90. So if I say 34 is greater than 90 and ask you whether that particular statement is right or wrong or true or false, you will say the statement is false. Exactly. This is the output you will tell me, isn't it? Like, you will say that this is false. So it means what this greater than symbol is doing, it is actually sort of saying whether the statement made by this particular expression is true or false. That's what it is doing. When you say a greater than b, based on the current values of a and b, whether that particular statement is true or false, it will say that thing. Okay, so since 34 is greater than 90, that statement is false, it is saying in false. So for example, now a is not 34, a is, say, 340. In that case, if I say now, say for example, 340 is greater than 90, and ask you whether that statement is right or wrong or true or false, you will say, okay, that is a true statement. The same thing will be done by this program also. Say a is equal to 340, b is equal to 90, and then you write somewhere c is equal to a greater than b. It means you are first computing, you are asking the computer to first check whether that particular statement is true or false. So whatever it is, you are asking the computer to store the result in this variable c, and at the end you are printing the result. So as a result, you can see for these values of a and b, like 340 and 90, you will see the result is true. Clear? Okay, that is what a comparison operator does actually. Only thing is that different types of comparison is there, right? Instead of comparing whether a is greater than b, you might want to compare whether a is less than b or not. Okay, let's say for example a is 340, b is 90, and I'm saying you that, okay, 340 is less than 90. Now your task is whether that statement is true or false. 340 is less than 90, that statement is false. So the output here, that is a less than b, will produce false. You will be storing it, you are storing it in C. So as a result, if you print C, you should see a false here. Clear? Say now it is 34, a is 34, b is 90. You are computing a less than b. Basically, you are asking the computer to check whether the statement a less than b is true or false. A less than b is, yes, in this case 34 less than 90, it is true. So as a result, you will see the output as true. Understood? Okay, up to that point, if things are clear, now let's see another example or another comparison operator, that is greater than or equal to. Quite straightforward, isn't it? Say for example, now here you write a greater than or equal to b. Now see, when you see, like suppose you don't know anything about programming, you don't know anything about operators and all, and you suddenly see this particular line, you might get confused actually, like, okay, there are two equal symbols and which one is doing what and what. But since you know that there is an operator, now see here how to interpret this actually. You have to think like, okay, this is the greater than or equal to operator, that and the operand of that particular operator is a and b. It means when the computer sees this entire expression, what the computer will do is, first it will compute this sub expression. It means what it will do is, it will first check whether the value of a is greater than or equal to b. Okay, now if I say 34 is greater than or equal to 90, it is false, right? So as a result, a greater than or equal to b will be false. That you will be storing in C, and then you are printing C. It means it will print you a false. Okay, now let me give you another example. Say now instead of writing a greater than or equal to b, let me go back to greater than symbol, but let me change this b again to 34. Now what you think will be the output of this program? Now a is equal to 34, b is equal to 34. Now you are like computing whether 34 is greater than 34 or not. Okay, and then whatever it is the result, you're storing it in C, and then you're printing C. So it means what you are asking actually, or what you are trying to, sorry, this thing suddenly, okay, what you're trying to do is, you're saying that 34 is greater than 34. Now, if I ask you whether that particular statement is right or wrong, what will you say? Whether that particular statement is true or false, what will you say? You will say it is false, right? I mean, 34 is not greater than 34. So certainly that statement is false. So if you write here a equal to 34, b equal to 34, and then you write c equal to a greater than b, obviously the value of c is false. As an output, you can see the value of c, the output of this program is false. But what if I write now here greater than or equal to symbol, or rather here in terms of this human level, if I say 34 is greater than, or I'm saying both the things, 34 is greater than or equal to 34. Now if I ask you whether this particular, what do you think, this particular statement is true or false? At this time, since I said both the thing, like, or I said or this or that, no? So since at least one part is true, you can think like, okay, that entire statement is true. The same thing here. When you say C is equal to a greater than or equal to b, it means right now the value of a is 34, b is 34. So 34 greater than or equal to 34, that will be evaluated as true. And then that true you are storing in C, and then you are printing C. Obviously, you'll see the result as true. Okay, got it? Okay, done. Now similarly, you can use this less than or equal symbol. Okay, say for example, if you simply say 34 less than 34, it is false. But if you say, instead of saying 34 less than 34, if you say 34 less than or equal to 34, it is true. It's true. Got it? So that's the difference between, like, this is actually called as strictly greater than, and this is called as greater than or equal to. This is strictly less than, and this is less than or equal to. Got it? And then these equal symbols, like two equal symbols, if you write together, what happens? Okay. Now for that, let me create a new code section here. Okay. There's a difference. And when you write a is equal to 34, and when you write a is equal to 34, these are two different things actually. Okay. Now this first one, when you write a equal to, although I said, like, when I was explaining you the operators the first time, when I started explaining, I said this equal symbol as equal to operator, but the actual name of that operator is actual name of that particular operator is the assignment operator. When you write single equal symbol, that is called as the assignment operator. Okay, the task of the, oh sorry, I did write here, and I did create a code section. I didn't want to create a code section. I wanted to create a text section. Okay, I just wanted to write something there. And when you write two equal symbols together, that symbol, those two equal symbols together, they form a new operator that is called as this equal to operator or equality operator. Okay, so you can call it like equality operator. A name really doesn't matter anything. Only thing that you have to understand is like, what is the difference between these two, and like when to use which one. Okay, so having said so, now you see, when you, this equal is assignment and equal is equality operator. Okay, now when you write a equal to 34, it means you are assigning the value 34 to the variable a. It means you are actually copying the right hand side value to the variable which is there on the left hand side. Okay, copying the right hand side value to the variable which is on the right hand side. That is the task of a single equal symbol, that is the assignment operator. Okay, now when you write these two equal symbols together, it is equality operator. It means what you're doing is you're not assigning 34 to a, rather what you're doing is actually you're performing an operation that checks whether the value which you have mentioned on the right hand side is exactly equal to the value which is on the left hand side of the operator. Here you're checking actually whether a is equal to 34 or not. Here you are actually assigning 34, or you're storing 34 as the value of the variable a. So as a result, now if you print, okay, since it is an operator that is like, this operator is actually producing a result the way a plus b produces a result. Similarly, a equal 34 also produces a result. So if you write c is equal to a equal 34 and then print c, and let's see what output comes. It will tell you that, okay, since a is 34, because you have stored explicitly 34 there in a, and then you are comparing that 34 with the literal, that the number 34 there. So obviously 34 equals 34, so you are going to get a true value here. But what if you write the same way, like on the same note, because this is also an operation, actually this is also an operator, it must produce a result, right? Say on that note, you try to write something like this: c is equal to a is equal to 34, and then you try to print this c. Okay, what it will print? So what it is doing is basically, see, you are it will be executing this statement from left to right. First it will see, okay, a equal to 34 means first it will assign 34 to this variable a. Now the value of a will be 34, and then again that value a, that is the 34, it will again try to store it in c. So now ultimately the value of c will also become 34. So as a result, if you print c here, you should get a 34 in this case. But here in this case, what you are going to get, you are now comparing the value of a, which is 34, with the value 34. Both of them are equal, so obviously the result is true. It means when I say 34 equals to 34, it is a true statement. So as a result, now you should realize that the result of this operation is true, and that true you are storing in this variable c. As a result, if you print now c, then you'll be seeing a true. So if you run this block of code, then you'll see, okay, the first print c is producing 34, the second print c is producing true. Just pause the video for some time and try to think, like try to make sure that these things are making sense to you. Okay, after trying for some time, if it really, if it still doesn't make any sense to you, then please write me in the comment section. Then I will help you in this case. Okay. But before that, give it a wholehearted try. I mean, these are simple things, right? I only can tell you. Understanding part is yours, actually. Okay? I'm not like, it's not that like I'm trying to, I'm trying to, what do you call it? What do you call it, actually, when you try to escape from a situation? Yes, I'm not trying to escape from my responsibility, of making you people understand, right? That is my responsibility. I know that. Then also, it is yours also. I mean, the best way of to understand something is first try to listen to it from someone, or maybe you can read a book, and then just spend some time, if needed, close your eyes and spend some time with yourself. Just try to digest the thing, try to make sense out of the things, and that way you actually understand a concept. Okay, done. Now hope you people have understood actually. Clear? Okay. Now, and then last one, then the not equal symbol. What is this not equal symbol to? As the name itself indicates. Now here you will be making a statement where you'll be saying that something is not equal to something, and then you'll be asking the computer whether that statement is true or false. It's simple, right? Okay, let me write this thing here. A is equal to, say again, 34. I don't know why am I liking this number 34. And A is equal to, say, 34, and then say B is equal to 90, and then you are writing somewhere C is equal to A, not equal to B. Not only, not equals B. Okay. Then okay, if you see something like this, you can think it of like it is actually same as writing this. Okay, you can put this bracket around it to make it more readable, but it really doesn't make any change in the output. Okay, so here also you can do the same thing. If something like this makes you confused, like what exactly it is, you can think it of in this way. That is a single unit. That is, whatever you write within this bracket, that part will be executed first, and then whatever the result of that part, it will be stored back in C. Okay, same thing here. Whatever you have written here inside these inside these parentheses, that will be executed first, and then whatever it is the result of that part, that result will be stored back in C. Okay, now you can use these parentheses to make the code more readable, but it is not needed actually. Okay, I mean, without writing these parentheses also things will work, but if since you're a beginner, I think writing those parentheses to make the code more readable is more useful. Okay, but okay, then we are not talking about this bracket. Actually, they have some meaning, they have a specific name, and they are also sort of operators. Okay, but in today's discussion, I'm just using them to make the code more readable. That's all. Now our main goal is this part. Now what you're doing here is you're saying that A is not equal to B. 34 is not equal to 90. That is true. That you are storing in C. So if you print now the value of C on the screen, obviously you'll see as true on the screen, right? Yes. Say for example, now you write A is 34 and B is also 34. You're saying that 34 not equal to 34. Obviously it is false, right? It's false. Clear? Understood? Okay, great. So that's all about these comparison operators. These are quite easy and straightforward things, isn't it? I mean, easy things, right? You don't have to even remember anything. It's just, you even do not have to type, right? And once I said you, and once you listen to me, I guess you people have got most of the things, right? But then also it's a good idea that you people type the things by yourself and do some practice. Try to check your understanding by yourself, and that way you'll remember it permanently. Even before exam, you don't have to. Suppose you people are writing an exam where your teacher might ask you some questions on these operators, right? So then also you don't have to actually read them before exams, because as I said, it's not about remembering, it is about understanding. Clear? Clear. Okay, done. Done. Right now, the last category of operators in for today's discussion, and that is your logical operators. They are again some very quite straightforward set of operators. Only three of them are there: and, or, and not. They are same as we use them in our day-to-day life. Now see, there is a peculiar thing again about these operators. For all these other operators, like say the arithmetic operators, the operators were symbols, maybe a single symbol, or maybe a set of two different symbols, right? Here also they were symbols like less than, greater than, or less than or equal to, greater than or equal to, like that. But in case of logical operators, they are like some English word, like this A and D. When you write A and D in lowercase, okay, this Python is case sensitive. You cannot writing A and D in lowercase is different from writing A and D in uppercase. Okay, so writing A and D, when you write A and D, in lowercase, it means that is an operator. See, that word and represents an operator. Similarly, that word or represents an operator. That word not represents an operator. Okay. Now let's see some example of these and, or, and not. Okay. So and means what? When you say and, like say in day-to-day life, okay. Say for example, Ram and Rahim went to the market. Ram and Rahim went to the market. Okay, you said that both of them actually went to the market. But if you say Ram or Rahim went to the market, then you said that, okay, when that statement could be true, when any one of them actually went to the market, you can say that, okay, the statement was true. I mean, if Ram only went to the market, then also when you say Ram or Rahim went to the market is true. Suppose only Rahim went to the market and you said Ram or Rahim went to the market, then also the statement is true. The way it is here, right? I mean, see this thing, greater than or equal to. Already that or operator you have used in some way, right? Like say, if you say like 34 is greater than or equal to 34, it is true. Because although 34 is not strictly greater than 34, but 34 is greater than, you said both the thing is greater than or equal to. Any one of them is true means it is true. So the or, actually when you say or, it means that any one of it, or when you say and, it means all of them. Okay, if they all of them should be true, then only the result is true. That is how we interpret and or in our day-to-day life. Okay. And what about not? Not is used to actually negate something. So if I say true, if I put a not in front of true, not true. Not true means what? False, right? If I say false and if I put a not in front of it, not false means what? True. So if something is true and if you say not in front of it, then it is actually the reverse of that thing. Got it? Okay, now that is an intuitive idea. Let's see some examples and you'll come to know. Okay, so for example, A is equal to, now see these logical operators, mostly these logical operators you'll be using with now Boolean types. I mean, Boolean types means what? That is another word, new word I'm using, but don't worry, we already have seen them. Boolean types means true or false. Okay, true and false. These are now when that word true and that word false, these are actually some type of data for the computer. The type of that data, although I have not said anything about data type, so let me skip that word Boolean. Okay, forget about Boolean type. Okay, but what about these and or you'll be using with typically, okay, you'll be using them with true or true and false. Okay, like this. So for example, A you can write as true and false. It looks very odd, no? True and false. But if I say true and false, what do you think is the result? True and false, no? True and false means false. So yeah, is it so? I mean, I have to show you something called as a truth table. But before that, I just want you people to like, I'm saying it in a different way actually. Okay, if I directly show you the truth table, then you will fall into something there. Okay, local optima. I mean, in my point of view. Okay, I just wanted to tell you some different point of views of the thing, and then let me tell you the most commonly seen approach. Okay, something I'm saying you. Yes, A equal to true and false, print A, it is printing you a false. Okay, now this true and false and print A, it is printing you false. Say what you can write in this way also. A is equal to, and see here, these words when you write true and false. Okay, here when you write true and false, you have to write it exactly true and false. I mean, T in capital, RUE. See here, true. Or somewhere if you see false, it is displayed as FALSE, where F is in capital, true, where T is in capital. So they are only meaningful. If you write TRUE all in lowercase, it is not a meaningful word for the computer in terms of Python. Okay. Now, why did I write these brackets? Yes, say for example, let me write here 34 greater than 78, and say I write here 78 greater than 23. here actually when I write 34 greater than 78, you know that, right? I mean, this part, the result of this particular expression will be either true or false. So directly you can write here true or false, whatever, right? And the result of this expression is again going to be true or false. So the directly also you can write a equal to true and false. Got the point? So that's why this is meaningful. It is not a nonsense statement actually. Okay. You got it? Yes. Okay. Now let's say, but we don't write. No, we don't. There is. I don't think there is any practical use of it. But then also, it is still a valid, expression in Python. Now, say for example, you are writing a equal to 34 greater than 78 and 78 greater than 23. These are quite commonly used ways of writing expression. Okay, when you try to solve some problems, then you might have to combine multiple comparison operators, the result of multiple comparison operators together. Okay, and this is one example of doing the thing. Okay, you're saying like 34 greater than 78 and 78 greater than 23. When these, now if I ask you whether this statement is right or wrong or true or false, you should realize that since it is an AND, it means that both the subcomponents should be true, then only the entire statement will be true. So 34 greater than 78, that's a false statement. Since it is false, without seeing the rest of the part, since there is an AND here, you can say that the result will be false. So if you print it, you should get a false here. Okay, false. This false is coming from this. Okay, but suppose if I write now here 34 is less than 78 and 78 is greater than 23. Both of them are true. See, 34 less than 78 true, 78 greater than 23 true. So true and true is true. So as a result, you will see here a true. Clear? Same way, okay, let me write here 34 greater than 78. That is a false. But here I write, instead of writing or and, I write here an or. Now what am I saying is that 34 is greater than 78 or 78 is greater than 23. Since I used or there, if any one part of this statement is true, the entire statement will be considered as true. So as a result, since this part is true, although this part is false, and since this part is true, it should tell me the result as a true statement. Got it? Okay. Similarly, the not. So not, as I said, no, if you put a not in front of the result, in front of a value, then it just tries to reverse the the especially Boolean value, true or false, then it tries to reverse the value. Like if you put a not in front of true, it will become false. If you put a not in front of false, it will become true. Let me show you this example. Say for example, a is equal to whatever it is, okay, and then you write, or rather if you put a not in front of it and put this entire expression inside this bracket, not here like this, okay, you just have to write this word not here, okay, like that. Now see, first, as I said, no, whatever you write within the bracket, that will be executed first. So this part will be, because this you have written inside the bracket, even if you don't write, but if you don't write, this not will be associated with only this part. But I want this not to be associated with this entire part. So for that reason, I put the bracket around it. And what is the meaning of it? The first thing is that it will be evaluating the internal part, right? Whatever it is there inside this outer bracket. 34 greater than 78 or 78 greater than 23. The result of this thing we already have seen is true. But since you put a not, and ultimately what you're doing is actually a is equal to not of true. Not of true is false. So ultimately here it will be printing a false. False. Got it? Okay, guys, that much only, I guess. But actually, before finishing this this discussion, let me tell you the most common ways of teaching people these and or not operators, and that is actually called as the truth table. A truth table is something like this: the value of the operand A, value of the operand B, and value of A and B B. Okay, here I'll be writing the value of A and B. These are just, I'm trying to create a table, and here I'll be writing the value of A or B, and here I'll be writing the value of not A and not B. You can think it of like I'm creating a table. These are the headers of the table. You'll come to know. A is equal to, it could be either true or false. T means true, F means false. B is say true, or they could be like true or false, or they could be like false or true, or they could be like false and false. Like only for, if there are two variables, each of them can have two distinct values, then only four possible combinations are there, right? So in this case, either they could be true, 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 false, false, true, false, false. No other possible combinations are possible, isn't it? No other combinations are possible, right? So what is the result when both of them are true? In case of A and B, in case of A and B, when both of them are true, the result is true. In case of A or B, when both of them are true, the result is true. In case of not A, whatever it is A, the reverse of that, it is false. Not B, whatever it is B, the reverse of it, false. Okay, now here, true, false, A and B, true and false, the result is false. True or false, the result is true. Not of true is false, not of false is true. Okay, okay, done. And what about this? False and true, the result is false and true. One part is false, so ultimately the entire result is false. False or true, false or true, one part is true, so the entire result is true. And not of false is true, not of true is certainly false, ignore it. And then false and false, one part is false at least, so it is false. One part, none of the parts are true, right? I mean false or false, both of them are false actually. Okay, so in that case certainly the result will be false. And not of false is true, not of false is true. It is not a difficult job, right? And that is, these are called as the, this thing is called as the truth table, that gives you the result of these Boolean or logical operators. Okay, so from this you can know, like say what will happen if you write if you apply AND operator with a true and with true and true as its operand, so it will be true. What will happen if you apply OR operator with, say for example, false and true as its operator, as its operand? Okay, so the output will be true, something like that. Got it? Okay, I guess the people have understood the concept, but then also if you have any doubts or queries, then if people let me know it in the comment section. I'd like to help you. Okay, okay. As soon as I go out of this thing, if I double click, you can see it in the form of a table, but if I click outside, it's showing you everything in the form of a single line. But I think that doesn't matter right now, right? Because you already have seen that table, and that's called as the truth table. Okay, okay then. So that much only about the the discussion, where I had to tell you like at individual level what these different operators do. Now our now the important part, like as I said, as I promised, that I'll be showing you a list of programs where we have to use these operators in some way to solve those problems asked in the programs. Okay, then let's do that part. Okay, these are the programs that I was talking about. Okay, let's try them one by one and check our understanding. What you people can do is that you can we'll be talking about this program one by one. So what you can do is you can pause the video and you can first try to write the program for this first one, and then you resume the video and check whether the program is same as the program that I write here. Yes, see one thing here, the program might be different. The program that you write might be different from the program that I write here. But the important point is that whether you get the right output or not. That's the main question here. Okay, and we have to write this program by using the concepts that we just learned. Okay, then let's begin the first program. Write a program to check if the sum of the two numbers is bigger than the first number. Say a equal to 2, b equal to 1, then the output should be true. That is, sum of the two numbers is 3, it is bigger than 2, so it is true. And say for example the numbers are like 2 and minus 1, some of the numbers are like 2 plus minus 1 is equal to 1. In that case it is not bigger than these two, so obviously the result is false. Okay, so how do you write this program? Okay, let me write it. Say you want to sum of the two numbers, so you need two numbers, right? So for that you create two containers. A is equal to some numbers, you just consider 2. B is equal to some other number, say minus 1. Consider b equal to 1, and then you compute the sum. So s is equal to, say for example, a plus b, and then you have to check if the sum is bigger than the first number or not, right? Bigger than the first number or not. Just have to do it in this way. C is equal to, that is your result. Let me write it in this way. R is equal to, R stands for say result. Result is equal to whether that sum is greater than the first number a or not. Okay, whatever it is that you have to print on the screen. So print it. That's all. So if you write a equal to 2, b equal to 1, the output should be true. True. If you write a equal to 2, any negative number, like if you add a positive number with a negative number, then the sum of those two numbers will certainly be smaller than the first number if the first number is positive. Okay, so if you write here a minus 1, then compute, you'll get a false here, right? Okay, it was quite straightforward, isn't it? Okay, done. Now write a program to check if a number is even number. Okay, that is also a quite straightforward program, I guess. So let's try to do it. Now, what is an even number? Like if I simply ask you, what is an even number? So a number is even when it is completely divisible by 2, right? And a number is odd if it is not completely divisible by 2. And how do you know a number is completely divisible by 2 or not? Now, you take the remainder of the division operation. Like you take a number, you divide it by 2 and see what is the remainder. If the remainder is 0, it means that number was completely divisible by 2. If the remainder was 1 or not 0, in that case, the number is not completely divisible by 2. It means the number was odd, right? That's what we have to do, and we know how to compute the remainder, isn't it? That modulo operator, you know. So that operator is a, like this is one perfect use case of that modulo operator. So let's do it in this way. We have to check a number is even or odd, right? Only one number, so one piece of data, one variable you have to create. Okay, a is equal to that particular given number, say 23. Okay, and then our result r is equal to a modulus by 2, because we want to check whether that number is completely divisible by 2 or not. Okay, so whatever it is, like now we have to print if it is even, we have to print true. If it is odd, we have to print false. And how do we do that? We know the result, like this is the remainder, but we have to convert it to true or false, right? So how do you do it? Okay, then this is r is not actually the result, actually say it is the intermediate result, remainder. Okay, and then what we do is the actual result is whether that remainder is equal to 0 or not. Okay, whether that remainder, am I doing a mistake here? Whether that remainder is equal to 0 or not. If it is not readable, then what you can do is, to make the code readable, I can put the bracket around it. Now what we're doing is we're just comparing remainder with 0. Now see, I'm not writing one equal symbol, two equal symbols, because here I want to use the equality operator, not the assignment operator, right? So here I want to check, like I want the computer to check whether that whatever it is the remainder, it is equal to 0 or not. Okay, if it is true, then true will be stored in the result. If it is false, false will be stored in the result. And whatever that result is, that is the final output. So print the result. Now see, if the number a is odd, then it will print false, because our question is whether the number is even or not, right? So if it is not even, it should tell us, okay, it is false. If it is even, it should tell us the result is true. Okay, let's see. 23 is odd, so it should say as false. Give any even number, say 2, so in that case it should be true. 0 is an even number. Okay, so if I write 0, what is 0 mod 2? 0 mod 2 is 0. So 0 equals 0 is true, so 0 is an even number. even number, right? So what about minus 12? Now minus 12 is an even number, okay, at least according to this program. It is completely divisible by 2, so in that sense it's an even number. Okay, done? Understood? Okay, great. The next one, write a program. It was also quite easy and straightforward, isn't it? Yes. Now write a program to check if sum of two numbers is equal to the square of the first number. What it is asking you is, say for example, if a is equal to, say for example 34, use some small number, and the other number b is equal to, say what, I say I want to make it 9, so I'll take 6. Now a plus b is your 9. 9 is the square of the first number 3. That is what it is asking you. Sum of two numbers is equal to the square of the first number. So in this case, the output should be true. But if I take here any other number other than 6, say for example 5, so obviously 3 plus 5 is 8, which is not the square of 3. So in that case, the output should be false. Understood? So that is the program which is asked here. Okay, so now if the question is clear to you, then what you can do is you can pause the video, you can try to write the code by yourself. Okay, but then also let me write it. Write a program okay, now sum of two numbers. So obviously we need two containers first to store those two numbers. A equal to, say for example 2, b is equal to some number, say 3, and then we have to compute the sum, intermediate result. So sum is equal to a plus b. Done. Now what we have to do is, if it is equal to the square of the first number, it means we have to also compute the square of the first number. So let's say square is equal to of the first number. So we want to compute the square of the first number. It means a raised to the power of 2. It means a raised to the power of 2, right? Yes, done. Then the final question, whether this sum is equal to this square or not. It's simple, right? I mean, say our result is equal to sum equal square. Okay, sum equal square. I'm putting a bracket just to make the code more readable, that's all. And then we'll be printing the result. Why is it showing an error here? Okay, done. Result is equal to sum equal square, print result. So in this case, the output is true or false, because 2 is 2 plus 3 is 5. 5 is not the square of 2, so certainly the result is false. So, but if you choose these numbers such a way that the sum is equal to the square of the first one, so you can come up with any pair, right? Say for example the first number is 5. So if you want the result to be true, then what this number should be? It should be the square of 5 minus what it should be. There's x is equal to say for example, what ultimately is the expression that we want to solve is like, square of the number, like square of the first number is a plus some variable x should be a squared, right? So it means if we want to know what is x is equal to a squared minus a, right? So that's what we have to do. So if we know what is a, see this x we have to find here, b actually. If we know what is a, then what is this b will be, like if we want to get the result as true, then a squared is 25 minus 5 is 20. So if I write here at 20, the output will be true, because 20 plus 25 is equal to 25, which is the square of 5. So the output should be true here. Okay, anything actually. So if a is equal to, say for example 7, what will be this other number? If you want to get the output as true, and it will be 49 minus 7. 49 minus 7 is 42. So if I write 42, I'll get true. Other than 42, if I write any other number here, I'll get the output as false. Right? Clear? Okay, understood, I guess, right? Now, this is the fourth question. Say a two-digit number is given. Say a two-digit number is given. Say, for example, the number is 23. Check if the first digit is same as the second digit in the number. It means you have to say if the number is 23, then output should be false because the first digit is not same as the second digit. But if the number is 22, the output should be true because the first digit is same as the second digit, right? Clear? Okay. How do you do it? To do that, we have to actually see, we have to separate the digits of the number. 2-digit number, it is given, okay? You know that always the given number has 2 digits, okay? So somehow you should be able to separate those digits. How do you do that? I already told you, right? This modulus operation can be used to separate the last digit. So you have to repeatedly use this modulus operation to, you know, like separate both the digits. So let's try to do it, okay? How do you do it? Okay, let's do it together. So first thing is you have to store the given number. So say the given number is A. Let's store it, say 23, 2 digits number. That is a strict restriction for this simple program. Okay, it could be arbitrarily long number. We can write the same program for arbitrarily wrong number, long number. But for that, we need to know some other concepts also. So that's why I'm just, you know, bringing here a simplified version of a bit more a slightly complex general problem. Okay, so A is equal to 23. Now we want to separate the last digit. We know how to do that. Okay, how do we do this? So digit 1, say for example, is what? Whatever it is A, if you perform A mod 10, you will get digit 1. And then you want digit 2. Can you perform digit 2 is equal to again A mod 10? Digit 2 is equal to A mod 10. Now let's print. It's wrong, huh? But then also I just want to show you digit 1 and print digit 2. Let's see what is the output here. First, see the digits. Digit 1 is 3. Digit 2 is also showing you 3. Okay, no, it's not the right output. See, this when you perform A mod 10, it gives you the last digit. That is okay, but it is not changing the value of A. A is still 23. So next time again, if you perform A mod 10, ultimately you're performing the same operation, 23 mod 10. That's we don't want, right? So after, you know, extracting this last digit, we want to change A. That is, we want to remove the last digit from A, right? That's the concept. We want to now remove the last digit from A. How do you do it? So, okay, then A is equal to A integer division by 10. Now, we know that if we do something like this, it will remove the last digit from the given number. So now A is equal to only, since it is only 2 number, directly you can use A as the second digit, but then also I'm taking the general approach. So now A mod 10 will give you the second digit there. Now if you print, you'll see that digit 1 is 3, that is this digit, this is digit 1, and digit 2 is 2, digit 2 is 2. Now your digits are separated, right? Now it is very simple. I mean, it is just like to check if 2 numbers are same or not, because you have now 2 numbers. Digit 1 is a separate number, digit 2 is a separate number. Only thing is that you just have to compare them and check if they're same or not. And that is quite straightforward, isn't it? So say the result. Result is equal to whether digit 1 is equal digit 2. And to make the code readable, I'm writing it in this way. And at the end, you have to print the result. Right? Right. So straightforward, right? Now let's see the output. If A equal to 23, we want a false as a result, false, right? Because 3 is not equal to 2 certainly, right? But if I give here A equal to 22 and I run the program, you will see the output is true, because see, both the digits are same, so the output is true. Don't you think it's nice and interesting? I mean, that's the, you know, importance of these operators. Operators are not there to, you know, like, you know, by heart and, you know, like, you know, somehow remembering them. Okay, these are the different categories of operators. Inside this category, these are the different operators. No. That is not the purpose of, you know, listing those operators and, you know, having these different kinds of operators. The actual purpose is so that we can solve some problems very easily. Okay, and these are some examples, right? Do you appreciate it? If you appreciate it, please let me know it in the comment section. I don't know about you, but when I learned these things for the first time, I was amazed. I mean, when I learned programming for the first time, initially I was very bad in programming, you know, like I really didn't understand anything. In the class, there was one ma'am. I mean, I'm talking about like when I was doing my engineering, I was in first semester, And I didn't know before that, before doing engineering, I never actually had any experience of programming or any touch with this computer science subject. So I was very new that time. But some of my friends, they already had some experience with programming. They learned programming in their class 12 or maybe in class 10. They were sort of experts. Okay, so in that class, many of the students, at least a good fractions or a good fraction of the students, they were knowing programming. They knew actually. And I was one like who didn't who didn't know actually programming. Okay, I was just one madam was there who used to teach us C programming, our first programming class, and she used to teach us something like this. She was a good teacher certainly, and I used to only look at her. I mean, no, I mean I was always thinking, how come she knows that she has to do something like this to get the output? And also not only her, some of the students, one student I know, his name is Rahul, his name was, or should I say is or was, maybe is because he's still there, no? Okay, anyhow, his name is Rahul actually. His name is Rahul and he used to know programming very well. I mean, he was an expert, really, he was an expert. And ma'am used to call him on the board and Rahul, please come and write this program on the board for the rest of the students. I was only looking at Rahul. I mean, Rahul, I was thinking in my mind, Rahul, how do you know? I mean, how come on earth, like you know that, okay, these are the statements that will solve the problem? No? And for that reason, I used to go to Rahul and I like asked him, like, Rahul, please tell me. Please teach me programming. And really, he was a very good friend of mine and he taught me programming. And really, I am very grateful to him. And, he really contributed a lot in my learning process actually. I learned a lot from him. That's a story, true story. Okay, anyhow, that's this program is done. Right now, the next question, say a 4-digit number is given. Write a program to check if the sum of the first two digits are same as the sum of the last two digits in the number. It's simple. I mean, the first thing is always, whenever a program is given to you, always you have to first understand what it is that the program is asking you to do. Once you know that, then comes the programming part. Okay, so if you can do, like, if you understand what it is asking you to do, somehow you will do it actually. So the main question is whether you understand the question or not. Okay, let's try to understand this question. Say a 4-digit number is given to you. Let's say the number is any 4-digit number. Again, the restriction is the number is a 4-digit number. Write a program to check if the sum of the first two digits, I'm considering these two as the first two digits and these two as the last two digits. Okay, so sum of the first two digits are same as the sum of the last two digits. Okay, so here it is the same. I mean, 5 plus 4 is 9, 5 plus 4 is 9, so it is same. So in this case, the output should be true. Okay, but if I write the number as 3, 6 and 5, 4, in that case also the output should be true. But if I write the number as 6, 6 and 5, 5, in that case, the output should be false. Most probably you understood the question which is being asked in this program. Now it's time to write the code. How do you do that? Again, we have to actually separate the digits. And once we separate the digits, like in D1, D2, D3, D4, rest of the things are simple, isn't it? Okay, let's do it. So for that, let's open this code and then write it. Say, for example, the given number is A, and there you store the number, whatever that number, 4-digit number is, 5454. Now separate the digit. So digit 1 can easily be separated by writing digit 1 is equal to A mod 10. It gives you the last digit. Okay, that is the last digit. It means in this case, this first digit, that is this leftmost digit. Okay, done. Once that leftmost digit is extracted, we don't need it anymore. Now our number should be 545. For that reason, we know how to like throw away the last digit, right, from a number. How do we do that? We write A is equal to A divided by integer division by 10. So that way we're changing now A from 5454 to 545. Now repeat the same thing for D2. D2 is equal to same A mod 10. Now it will give us the this number 5 here, right? And then so if I guess people are following, right? Yes, D2. Now since we have this D2, it means this number, this digit is also like taken away from the number. So now we don't need this 5 also. So we have to throw this 5 away from the number. So again, we'll be writing a is equal to whatever it is the a now. You perform this integer division by 10. So now 5 is also gone from that number. That is 5 and 4. These two digits are gone. So only left is this 5, 4, the first two digits. Okay. So now from this first two digits, first we want to extract the last digit. That is from 54, we have to extract this 4. So it means D3 is equal to whatever it is a mod 10. Once we have that, now we don't need the last digit also. So we'll be throwing that last digit. A is equal to a, mod 10. And then whatever it is left, now only we have the only one digit, but then also following the general steps, I'm writing D4 is equal, I can directly write D4 is equal to A here. Okay, but I'll write here D4 is equal to A mod 10. Okay, now our D4 A mod 10. Now our D1, D2, D4s are ready. So let's print them and check. Print D1. I could have printed them on the same line, but just to make the code more readable for you people, since you people are beginners, I don't want people to I don't want to create any confusion for you, okay? Because that's not like printing something on the same line is not right now is not our main concern, right now we're learning something else, so I'm keeping that thing aside. So let's now print these digits D1, D2, D3, D4, and let's see whether it is the right digits or not. Okay, it is saying 4 5 4 5 4 5 4 5, right? Now let's write these digits as 1 2 3 4. All the digits are different, right? So in this case the numbers are like 4 3 2 1 in the reverse order. 4 3 2 1. Okay. The main task is done. Now only thing is that the sum of the first two are same as the sum of the last two or not. So you know that how to do it, right? Sum of the first two, so I'm calling it, say the sum of the first two is SF. There I want to store D1 plus D2, and sum of the second two the last two is say LF. Sorry, what is that? Sum of the last, so SL. You can use any variable name, right? So D3 plus D4. Now your actual result is equal to whether SF is equal to SL or not. Okay, that's all. Just to make the code more readable, I'm putting these brackets around that. That's all. And only thing is left is printing the result and check whether your program is right or wrong, right? Now, if I give the numbers as 1, 2, 3, 4, certainly 1 plus 2 is 3, 3 plus 4 is 7, 3 is not equal to 7, the output should be false. False here, right? But if I give, let's make it 7, 1, 6, 3, 4, the output should be true because 1, 6 is 7, 3, 4 is 7. So the output is, why it is not? Then I'm doing a mistake. It's giving you, here I wrote D1 plus D2. Okay, sorry. I'm sorry. Now it should be true. It should be true, right? Right. Clear? Okay. You can try with any other combination. Maybe I did another mistake somewhere unknowingly. So let's say 5 4, which is 9, and say 0 9, which is also 9. It should give you the output as true. Okay, let's try all of them to be the same. I mean, I want all the digits to be same, and also I want the output to be true. What that number could be, let me know it in the comment section. The number is, according to me, 0 0 0 0. All the digits are same, but the output is also same. Okay. But you can actually come up with all the digits. When all the digits are same, then always the output will be true. Actually, I didn't have a thing that much, right? Even if I write 7 7 7 7, output will be true. It's not a big question. Actually. I'm sorry. Okay, but anyhow, I guess people got the point, right? Yes? Yes, okay. Now say another program, the next program. Say a 4-digit number is given to you. Write a program to check if any one of the 4 digits is an odd number. Simple. I mean, like in this case, say for example, if say a 4-digit number is given. Say the number is A is equal to this. 4-digit number, again restricted version of a general problem. Okay? 5454. Write a program to check if any one of the 4 digits is an odd number. Since there is an odd number here, this 5 is an odd number, at least 1 is odd, so the output should be true here. Okay? And say for example, A is equal to 2 4 6 8. None of them is an odd number. Output should be false. Say the output is 3333. All of them are odd. Since at least one of them should be odd to make the output true. In this case, the output should be true. Got it? So that's the program we have to write. First thing again here, what we have to do is we have to separate the digits. We already know how to do that. And once we separate the digits, the next question will be like, how do we like check out of all these four, at least one is odd or not? Okay, that's the thing. You can try it by yourself. You can pause the video, you can try it by yourself, and then you also can let me know it in the comment section, like, okay, I got it right, I got that right, I got that one right, I got all of them right. I'll appreciate this. Okay, but even if you cannot do, but you tried well, that is also quite appreciable. In fact, that is more appreciable, no? Because making mistakes is actually a lesson, like if you make mistakes, it means that you are learning actually, and your learning is more concrete in that case, because since you do a lot of mistakes, it means that like how things can go wrong, what are the different ways that things can go wrong. But luckily, if you get it right in the first attempt itself, you are unaware of the maybe it might happen that you are actually unaware of the situations where things might go wrong. So it's a good thing actually when you do mistakes. I really think so actually. Okay, done. You might not think that way. That's okay, no problem. We are different human beings, different thinking. Obviously, it should be there. Okay, now what is our point? An odd number. Yes, okay. Now our goal is like we have to separate those numbers, and then we have to check if at least one of them is odd or not. Okay, so let's write the code. Take the number, store it somewhere, then separate the digits. You already know it, so we already have done it, right? D1, D2, D3, D4. So I'll be copying this code. Separation of the digit is same as this problem. So we are separating the digits, and we are printing the digits also. Now our question is, we have to check if at least one of them is odd or not. So I can write it in this way. Result is equal to D1 should be, D1 is odd or not. Okay, D1, how do you know whether the number is odd or not? You perform the modulus operation by 2 and check if it is equal to 1 or not. If it is equal to 1, it means this is a odd number. The number is an odd number. This is how you check actually whether digit 1 is odd or not. Similarly, you have to check whether digit 2 is odd or not. Okay, let me make the, I could have written it in the same line, but no, let's do it step by step. Digit 1, is digit 1 odd? Is D1 odd? That will give you the answer. Okay, either true or false. Similarly, I want to check if D2 odd, if D3 odd, if D4 odd. Okay, this is D1, this is D2, this is D3, this should be D4, and this one D2, D3, and D4. Is D1 odd? Is D2 odd? Is D3 odd? Is D4 odd? We have computed all of them separately. Now, when should be the result true? When at least any one of them is true. And we know how to do that, right? Result is equal to, is D1 odd? Okay. Or is D2 odd? Or is D3 odd? Or is D4 odd, right? Is D1 odd? Is D2 odd? Is D3 odd? Or is D4 odd, right? Any one of them odd, the result will be odd. Just print it and check it out. Okay, let's run the code and check. In this case, the number was 1, 2, 3, 4. These 1 and 3, they are odd, so certainly the result should be true. Let's make a number where none of them are odd, like all of them are even. Say 6, 6, 6, 6. In this case, the result should be false. Let's make it like 6, 2, and all of them are different even numbers. 6, 2, 4, 8. Okay, the result should be false. Let's make this one as odd number, and the result should be true. All of them odd. Say 1, 3, 5, 7. The result should be true. Okay, got it? Done. Now the last question. Say a 4-digit number is given. Write a program to check if all the 4 digits are odd numbers. Do you really want me to write this code? Just pause the video and try to write it by yourself. If you can write it right, then let me know it in the comment section. Okay, but then also just to complete, just for the sake of completion, I'll be writing this program. This program is exactly more or less the same program which we just wrote. So first what I'll do is I'll copy this code and I'll paste it here and only do the change wherever it is needed. Okay, so here the question is up to 4-digit number, check if all the digits are odd numbers. Okay, separating the digits, whether each digit is odd or not, up to that point everything is same. Only thing is that now our result should be true only when all of them are true. So if we want that, we have to use this AND operator, because we want a true when all of them are true. And how do you make sure that the result is true when all of them are true? Just by using this AND operator. That is, it also should be true, it also should be true, it also should be true, it also should be true. Then only the entire result will be true, right? And when I say this is true, it means the first digit is odd. This is true means second digit also should be odd, third one also should be odd, fourth one also should be odd. Okay, now let's run this program and check. Here all of them are odd, so certainly you should get it true. Yes. Okay, now let's make this one as even, say 2. In this case it should be a false. Let's make this one a even, but this one as odd. Okay, so it should be false. Let's make all of them odd. 2 2 2 0. Run it. Odd, it means false. So this output will be true only when all of them are even. Sorry, all of them are odd. Say maybe like 9 7 1 3. In that case the output should be true. The output is true. Okay guys, then that much only in this part of the video. Hope you people have understood something from this part of the video, and if you have any confusions or doubts which is not clear from my explanation in this part of the video, then please let me know it in the comment section. If you like this video, then please press that like button, and also share this video with your friends. Like if you think that this video could be useful for some of your friends, then please do not forget to share this video with your friends. Okay, and also please, if you like this video and if you really think this video is really is useful for you, that in that case do not forget to subscribe the channel. I really do need some subscribers and to grow my channel, and it will be like quite motivating for me if I see a lots of subscribers. Like I always think, like I'll wake up in the morning and I'll see like thousands of subscribers. Yes, I know, I mean it's not it will happen certainly one day, I guess, if I like keep on pushing myself and trying to improve my content. Certainly it will happen one day, but every day I expect that thing. I mean that's the reason. I mean that's really something that but again, yes, as I said, or as I say always, do not subscribe or do not like simply because I ask people to do, right? I mean please do it only when if you really like the video, if you really wanted to subscribe the channel. That will give me the confidence, like okay, seriously people are liking it, seriously people are subscribing it because of my content, not because of my requests. Okay, so forget about my request. If it is like not worth seeing these videos, not worth liking these videos, it might happen. No, I might think that these are good, but for many of you it might not be good actually, right? It might happen, right? So in that case, do not do that. I mean, whatever I see, it should actually be a clear picture for me. I mean, yes, do subscribe, do like, even if you think like 1% that okay you're liking, 1% that okay you should subscribe, then also you do it. But if it is completely 0 or negative, obviously you will not do that, right? Okay guys, then that much only in this part of the video. See you guys with some new content in the next part of the video. Till then, sorry, I should look here. Till then, have a nice day.